good evening, and welcome to the Hashi Talks. And welcome to my talk, What's Happening? Getting started with the Grafana-flavored OpenTelemetry setup for Nomad. I'm Max Fröhlich. I work at Serviceware as a platform engineer. At Serviceware, we have a lot of different software and services for IT, HR, finance, facility, and service management. We have a lot of different teams with a lot of different, they use a lot of different technologies. So be it Java, Python, .NET, Go, JavaScript, and more, I think. We are moving more and more forward in our Nomad-powered cloud. But this also means teams need to take more ownership of their deployed applications. More and more services are starting to talk to each other. Different languages with different logs, and really getting insights from the Nomad UI are very ephemeral. Therefore, for us, it's often the question, what's happening? Luckily, by this point, OpenTelemetry matured. OpenTelemetry is an observability framework and toolkit to be designed to create and manage your telemetry data. But what's observability? They define observability by understanding the internal state of your application by examining its output. Especially in a context of software, this means understanding that state by looking at the traces, metrics, and logs. So just to recap, what are those so-called signals? Metrics is the measurement that's captured at runtime, the memory usage, or the login count of how many users logged in. Logs is something with a message and a timestamp that just is printed out somehow, and you can maybe read what is happening there. And also traces. These are visualize the path of, let's say, an HTTP request your frontend sends to the backend, and you see in this trace a lot of tiny steps that happening when that request comes to your backend. And all these tiny steps, also called spans, then make up one trace. And since there's usually a lot of more microservices involved when you handle one request from the front end, these traces are often also distributed. So observability, I think everyone is doing this kind of somehow already. Maybe you have logs printed out to your STD out, and then it's collected by a sidecar and sent to the Elk stack. Maybe your metrics are scraped by Prometheus and then saved in the Prometheus backend, or your traces are pushed to a Jaeger server. But usually, or in a lot of times, those are three isolated pillars where how you collect your data, and you have to configure them individually. And between the data you collect in the one backend and the other backend, there's no explicit correlation. So it requires a lot of context switching also to when you start analyzing the state of your application. Mm-hmm. So OpenTelemetry is the one framework to rule them all. What does it bring to the table? First of all, a lot of specification. There's the OpenTelemetry specification itself that defines the structure of signals and resources. There's the OTLP, which specifies APIs and encoding and the transport. And there's the semantic convention, which tells us how to name things. There's also code, which means like there's an API that you can use in your code to produce those signals, and there's a SDK, I think, for every language that is out there, or at least the common ones. There's also something called a zero code instrumentation, so you don't have to touch your code at all, but you can somehow instrument your application. And for all the libraries you usually use in your code, for all the nice libraries you like to use in your application, there's the community provides a vast set of instrumentation for all these common libraries. And finally, there's also the collector, which is a tool that helps to receive all those signals or extracts them from different sources, process them, transforms them, and then exports it to all kind of backends you have. And it also comes in different distribution and can easily build a custom package with out of that collector as well. So let's look at the step by step. We have our application. Our application is then somehow instrumented with the API and the SDK or the zero code instrumentation. And suddenly it produces metrics, logs, and traces, or spans to be precise. Those signals all have a certain shape or form, like a model in a certain way. That means your metrics has a name and a value and some more stuff and some attributes, and also reference the resources. The resource it was, and the logs also have a timestamp and a body, and there's a span has a span ID and a trace ID, and all those fields are also like these attributes. And our applications, as you see here, is also called a resource now, because a resource in the OpenTelemetry world means it's the entity that produces those signals. These models are all defined in the OpenTelemetry spec. The attributes that you can set on all these signals are you can put whatever you deem relevant as an attribute into those signals. But there the semantic convention already provides you with a huge set of recommended attributes fitting to a certain use case. And most important here is the service name and the service instance ID as part of your resource attributes. Because throughout the system, this is the main identifier for where those signals came from. But as I said, you could use different, you can also use different attributes that make more sense for the signal itself. So be it the DB system name is Postgres, or the exception type of that is somehow attached to a log is a null pointer, or the HTTP request method for that span is get, or something like that. And the semantic convention here specifies really a lot of different attributes that fit a certain use case. So then our data is forwarded to the OpenTelemetry collector, which then transforms and processes those things. And there can be multiple collectors, and somehow they are put together. And then they forward it to some backends. The overall transportation here from your application to the OpenTelemetry collector, and if you want to use their API, this is all specified. The OTLP API and the transport and the format of this data is all specified in the OTLP spec. Right. These are the main components. So for the backends, the OpenTelemetry does not really mention anything, as there are a lot of different vendors out there providing backends for any kind of those signals. But maybe as my title foreshadowed it already a little bit, we're concentrating ourselves today on the LGTM stack from Grafana, which means you have Loki that stores the logs, Grafana for the exploration, and Tempo for traces, and Mimir for metrics. So this in the event for us, this makes the Grafana LGTM stack or single pane of glass for OpenTelemetry data. They're all easily scalable. I said Loki is for logs. Grafana is the visualization platform for exploring and creating dashboards and creating alerts. Tempo is the backend for traces, and Mimir is the backend for metrics. Mimir here is also so-called scalable Prometheus backend, which comes with the regular PromQL interface. Yeah, those backends are easily scalable. We started small, and making them bigger from time to time. They all work well with the common object stores that are out there. This means for us we use an S3 backend to store all our telemetry data. And the good thing also about these backends is that they all have already a native OTLP endpoint to ingest OpenTelemetry data. But there's more. As said, the OpenTelemetry collector itself can be distributed and wrapped in easily, and Grafana provides the Grafana Alloy as a OpenTelemetry collector, which we are also using here. The cool thing about the Grafana Alloy is that it brings some extras, and it's a regular OpenTelemetry. It has all the regular OpenTelemetry collector features plus some extras. Firstly, it comes with an HCL dialect, so the configuration language is very similar to the rest of the HashiCorp products. It lets you easily build your processing pipeline. It has a nice debugging UI if you want to see what the configuration looks like. It has programmatic features in there in case you want to read and parse some configuration files that are in JSON or something like that, or you want to access some environment variables, and integrates also nicely with Vault. It has more fun in it, but just here to name a few. So let's deploy our OpenTelemetry infrastructure, right? On Nomad. But first of all, I want to talk a little bit more about the deployment modes you could do with your OpenTelemetry collector. As said, our LGTM backend has already a native interface for OpenTelemetry data, so theoretically we could just, from every application we have out there, send the logs, spans, and metrics directly to the backend, and we would be finished. The only problem is that potentially will directly produce a high load on your backends, and also you have to think about access there in terms of who's allowed to have access, and also maybe the backends are living in a different cluster. So you would need to bring all this information somehow to all the applications you want to get your signals from. Therefore, the OpenTelemetry collector here comes as a so-called agent, which means OpenTelemetry talks here about the so-called agents, which are deployed quite closely to your actually running applications here. And let's say we have a node on which are several applications running. They all send their data to this agent. While on the other node, there's another agent where it receives the signals from the application deployed there. And then it's forwarded to the OpenTelemetry endpoints. And here, the cool thing is they can already do some pre-processing, augmented the data they are receiving, and also batch it and send it then forward in batches. So the backends just receive way less requests, but like in a batched manner. So we could also use this approach, but the only problem here is, or it's not a problem, but what happens then is when you look at traces, and especially in their distributed nature, we get a request here in our application, and this somehow calls the next step and the next step. So all these applications produce a span and send it forward to the agent, and then they would end it up here. But when you want to do this and say, hey, I want to take 100% of all the traces and keep 100% of all the traces I'm getting, this will be very expensive on your backend. And for us, we noticed like really how much disk space we started using when we did 100% trace sampling and storing all the traces. Well, to mitigate this, you could either do one thing. You can here, when your application gets a request, the application could do a so-called head sampling, where you say, hey, I flip a coin and I'm just like going to sample, I don't know, 50% or something like that of the of the requests I'm getting. The only problem is you may lose the interesting traces, and yeah, it's just like a simple but a simple way to measure to collect traces and to reduce the amount of traces, but you will potentially lose the interesting ones. Therefore, OpenTelemetry comes with another concept where they just deploy another layer of OpenTelemetry collectors in here, where they say these are the so-called gateways. And what happens now is that for each request the application gets, it produces it doesn't do any kind of head sampling, but it forwards all the spans it produces. But the OpenTelemetry agent then starts routing the spans by trace ID. So you can make sure like all the from one request, all the spans are ending up in that gateway, while the other requests from the second request are ending up that way. Which then allows you to do tail sampling, and tail sampling, tail sampling means the OpenTelemetry collector then looks at the whole trace, at the whole completed trace, and then decides, hey, is it a cool trace or not? Is it like maybe does it have errors so somebody should look at it, or did it take long? Did it take long? If any kind of those policies match, then yeah, you're being forwarded. While like, well, I don't know, these are just like one of these 100 millions of okay traces that don't say anything specific. So we're just going to sample and say like, hey, just keep like 10% of them. All right. So let's put our Nomad glasses on and see how we could deploy this in here. As we said, we have the agent and the gate we want to deploy. So the first thing we're going to do is we deploy the agents, and those we deploy as a system job. So for every deployment, for every new Nomad client you're going to provision into your Nomad cluster, it will have automatically a running agent on, and it has a fixed port, and the app knows directly where to send its telemetry data on. No complicated service discovery or something like that is required. They have their port where they send the telemetry data to. The OpenTelemetry collector gateway then can be just deployed as a regular service, but redundant. So let's say you put in your service job the count to 3, and or whatever seems like a good high availability, and then it's forward to the LGTM stack. All right. Let's have a short look at the Nomad jobs of the agent and the gateway, and see what we can, how they are configured. So first of all, we have the OpenTelemetry agent job. As said, it's of a type system, so it's deployed everywhere. As we said, it has a UI, and it also exports statically our two services to our two OTLP endpoints here. Then we have the Alloy agent here, and it uses those ports. It has a configuration which we're going to look at in a second, and apparently, so in our OpenTelemetry agent, we said we're deploying it as a system job, and we just deploy it for all the data centers we have. And you see here it has a network, some network ports. Here's the UI, and then it has these common OTLP endpoints to collect actually data. The gRPC one is the 43107, and the 4317, and the HTTP one 4318. We use the Grafana Alloy image as the collector. We said we have a configuration living here, and we see that's we have a look at this configuration in a second, as well as apparently we look up all the gateway OTLP endpoints and run them in a gateway YAML file. So the configuration of the the Grafana Alloy, as said, is a HCL dialect. As you can see, it looks very similar to what you used to be in the HashiCorp configuration language. Besides that, they have here sometimes some namespace in here, but the rest is very, very similar. And we see here our agent has an OpenTelemetry collector receiver for both kind of protocols. And then we're going to forward them to the Nomad attributes transformer, process transformer. In here, we can already enhance our incoming signals and adding additional metadata, which we have. In this case, we're going to set the Nomad node data center to the value we're running in. And yeah, so we're going to set on those resource attributes of the signal. We're going to set Nomad node data center there as well. And we do this for metrics, for logs, and for traces. Then as said, is a certain batching happening, so therefore we are forwarding it to a batch processor, which then forwards it then in batches to the next step. In this case, our batch processor then sends it forward to this client-side load balancing we're doing, and it sends the metrics and the logs going to send to a load balancer that routes by the service name, while the traces are then routed by trace ID. And we see here the gateways are looked up from that file, and then by a service we have the load balancing by service due to routing key service. We're going to send it anyways to the gateway, and here we have the load balancing by trace ID, where we say like this is routing by trace ID, and it forwards over also forward to the gateways, but routed by either the trace ID or the service name of that signal. The gateway deployment looks very similar to the agent one, but with the difference we're going to deploy this as a service. We're setting the count to 3 to have 3 gateways available. Those also exposing the OTLP gRPC and the OTLP HTTP endpoint, but in this case on a random port, because those are just used by the agent. And it has also like a configuration in there, and further it looks up the log metric and traces endpoints of Loki, Mimir, and Tempo. And here in the gateway, we have a very similar setup, but yeah, we're looking up the backends. We have the backends in that file, and then we have also the OTLP receiver, as we also receive OTLP signals here. Metrics and logs are just batched and sent to the batch processor, while the traces that are coming in are sent to the tail sampling processor. And here we can see we have a policy in place that we say, hey, we want to keep all the traces that contain errors because those are the interesting ones, but for the rest, just keep like 50% of them. So we only keep half of the OK traces. And it's also just sent forward to the batch processor. The batch processor then just sends it either to Mimir, Loki, or the tracing endpoint. You just see those exporters, those OTLP exporters then. So how does this look from a Nomad perspective in the UI? We see our OTL agent living here, and if we go to that one and here look at the UI, we can also see we get a configuration here, and in here you see actually the debugging UI that showcases you how the pipeline is configured. Also, we have our Grafana living here, where you see like we have Tempo, we have Loki, we have Mimir, but just looking at the logs, you see it's very empty, as no signals are sent there. So now that we have our OpenTelemetry infrastructure in place and the pipelines and the collectors set up, let's start to instrument some applications on Nomad. First, we need to instrument our application. We can do this either by using the API and SDK ourselves and putting the code in our code and modify our code, so we can be very specific where and which parts we want to get some telemetry data from. The other way is to use the zero code approach. This is where the OpenTelemetry community provides tool for each programming language that's out there that weaves in the instrumentation without you need to touch actually your code base, which is a great way to get started. From the configuration perspective, you don't, it doesn't matter. You can use environment variables. It doesn't matter if you use the SDK or the zero code tools. The most important thing you can set or need to set is the OTel resource attributes, where you specify your service name and your service instance ID that you can later on identify your application, as well as the exporter endpoint where the exporter should send its data to. So yeah, it's actually the exporter of the SDK or the zero code tools is actually shipping the code. For our demo, I have like 2 Java applications that are already deployed but not instrumented yet. One is called a Hello World application, and the other one is the salutation provider, which provides the salutation for our Hello World application. To get started with the zero code in Java, you need to set up a few things in your deployment. You need to provide a so-called OTel Java agent, which is told that which the JVM takes, and this agent takes care of weaving in all the instrumentation. We tell the JVM via the Java tool options where that Java agent lives, and then we just need to set up the rest of the OTel environment variables. To do that, we can see how we have a look at our instrumentation code here. On the left side, you see our the regular Hello World application Nomad job, and on the right side you see the instrumented one. You can see we can use the nice artifact feature of Nomad to download certain things from the internet before the application actually starts. In our case, we're going to download this from the Java instrumentation, the OpenTelemetry Java agent jar, and place it in the local directory. And then we're going to tell them here to tell the application, here is the Java agent. And here are the resource attributes. We're just going to use the task name as well as the Nomad short alloc ID as the ID. And then we just tell them that the OpenTelemetry collector agent lives here on that port and is just the fixed IP address of our Nomad client. So the same has to be done for the salutation provider as well. So let's deploy the instrumented versions. And we do the same for the salutation provider. And then we head over to the Nomad UI. In the Nomad UI, we can look at our Hello World example and look at the definition, and we see here's the Hello World, here's the OpenTelemetry Java agent now downloaded, and here are all the additional details required. So let's see if we got some logs now. And yes, automatically we received already some logs. That's great. Now let's actually try our application. First, I'm going to open the Hello World application. And here you see, oh, that's a great application. I can greet someone. So I'm saying, nice, hello Max. That worked well. So let's try foo. Oh, that also worked. So one more try. Let's greet HashiCorp. Oh no, something failed. Let's head over to the logs and figure out what happened. So let's refresh here. And we see there's already an error happening in our Hello World application. Let's dig into that. We see, okay, greeting the HashiCorp, but then apparently there was an error. Okay, a general server error, that's not really helpful, but let's see what else is there. We can see the whole stack trace in here. Okay, that's not like maybe it's not still on my problem, is it? I don't know. Let's check. There's the link to the whole trace of our application, and since we are making sure we're sampling the error traces, this trace is present. And here we can scroll down and we see, here's our Hello World application, and did a get call to the salutation provider. The salutation provider tried to find something in a repository and was executing some selections on it. Was executing some SQL queries, but for some reason we notice here's something off. So when we look in here, we can even look at for further details and see, for example, in the span attributes. Here's the full URL that was called. It was getting the get salutation name for HashiCorp, and this for some reason failed. And I can also click here, and apparently here was something also wrong. And there's an exception, no such element exception. Okay, what happened in here? Then we can go jump back to the logs again. And when we scroll down here, let me just make that a little bit smaller here for better overview. And we can see, okay, there was apparently an error, and especially there was something just before that error for the no such element error. There was something like looking for salutation with ID -1. -1 sounds a bit funky, so let's copy that thing and see if we find something in the code for that. In our code, we're going to search for that log message, and we see, and apparently someone was trying to program a deterministic random on the given name, but it's apparently very buggy. So time to file a bug report, but we can very precisely tell now already where this issue happened. So great. So now we saw, without touching any line of code on our application itself, we got already a great amount of observability out of our application. We could even see how applications are talking to each other and what they're precisely doing by looking at the traces. So now we could be good to go, but we have apparently a lot of microservices since we deployed loads of them, and we have loads of Nomad job files. So we need to have to put this configuration parts in all our Nomad configurations, and that's maybe hinders us to move forward faster, and because we need to notify all the developers to please put that thing in your Nomad job file. So is there maybe a way to even do like zero code instrumentation for the Nomad job file? And for that, I wanted to showcase my little side project called the Nomad Admission Control Proxy, which is a proxy that sits in front of the Nomad server, and it takes in incoming requests and can mutate and validate these submitted jobs. So every time you run plan or run or something like that, it takes the job and runs it to its processors and do something on them. It does this via an embedded OPA or OPA engine. Also can just send it to a remote hook and get results from there. And now, just for a final demo, let's try to inject all these OTel instrumentation details on the fly by leveraging the Nomad Admission Control Proxy. So the Nomad Admission Control Proxy and the embedded OPA engine use a language called Rego to take the Nomad job, which is eventually a JSON file, and then either validate it or even create JSON patches for that document to patch it up and by therefore mutating it. So let's have a look at this OpenTelemetry rule for a second. you can see here I'm creating a patch to add the artifacts block. And here I'm going to create another operation that patches and it goes to the artifacts block then and puts in this artifact download thing, which points to the Java instrumentation. Then I'm going to work on the environment and put in the Java tools option where I specify where this Java agent lives. And then finally, I'm going to set all the resource attributes and put like loads of additional resource attributes in there, like the Nomad Alloy ID, the service name, the instance ID, and then also the Nomad Alloy ID, the name, the index, the group name, the job ID, the job name, the parent ID, also which type it is, and all those things that might be interesting later on to search for them. So the proxy is running on a similar port as Nomad itself. And now if I go back to our Hello World application and instead of deploying directly to Nomad, go via the proxy by telling it here, instead of the Nomad address, I'm going to set it to 6464, which is where my proxy runs. But I'm going to use the Nomad CLI just to run my regular uninstrumented Hello World job file. And I'm going to do the same I'm going to do the same for the salutation provider. So let's head over to the Nomad UI again and see what happened. In the Nomad UI, when we inspect now the Hello World shop and look at the definition, we can see there is no more OpenTelemetry code inside the regular HCL spec. But if you look at the full definition right now, you will see that in here, suddenly there is the Java tools options, and then there is the auto resource attributes block, which sets all these interesting details we just injected with the Nomad admission controller. And also, we also see that the artifacts block is inside, even though it's not present in our job spec, but it's in the real definition in there. So did this work? Let's have a look here in Grafana and go one more time to the logs. Here's the redeployed job, and we can see, and let's greet our one more time and say, hello Max, hi application. And now if we check the logs, we see, hey, greeting the user, and you see everything is there, even all the additional resource information we just put in. So that's it. That was OpenTelemetry on Nomad. We looked at basic building blocks of OpenTelemetry and different ways how to use the OpenTelemetry collector. We deployed the Alloy OTel collector and sent data to the Grafana's LGTM stack. We instrumented some Java applications without even modifying them, and then we leveraged also the admission control proxy to even instrument the Nomad job files without touching them at all. So yeah, so we saw without any code instrumentation or without any code changes whatsoever, we got instrumented Java applications that produce data and sent to the to our backends. I find this pretty cool. Thank you.